Hello and welcome back. For this example, we want to find the absolute max and min for this function g of x, which is e to the x times the cosine of x on the interval from 0 to pi. And in the previous video and in our lecture notes, we know that there's a four-step process which involves us evaluating the function at the endpoints, finding critical numbers, evaluating the function at the critical numbers inside of the interval, and then comparing the values at the end to answer the question. So the first thing we're going to do in this problem is we're going to go through and evaluate the function at the endpoints of the interval. So we're going to calculate g of 0 and calculate g of pi. So g of 0 is just going to be e to the 0 times the cosine of 0, which we know is just 1, since both those numbers are 1. And then g of pi, well, that's e to the pi times the cosine of pi. Well, e to the pi is exactly e to the pi, and the cosine of pi is negative 1. So the exact value is negative e to the pi, and a calculator will tell us that's approximately negative 23.1. And one decimal place should be enough for us to get an idea of what that value is. So step 2 of the process, that's to get our critical numbers. And in doing so, we need to find our derivative. So g prime of x is going to require the product rule. Derivative of the first is e to the x times the second plus first, coincidentally e to the x, times the negative sine of x, which is the derivative of the cosine function. If we factor that down, we can take out a common e to the x, and we have a cosine of x minus the sine of x in parentheses left over. So it should be noted that this derivative is never undefined, since it's the product of continuous functions, but it may be equal to 0. So we're going to set g prime of x equal to 0 and algebraically solve. So that's an e to the x times the cosine of x minus the sine of x equal to 0. We know that the exponential function is never equal to 0, so we can safely divide by it to remove it from the equation. And that leaves us with the cosine of x minus the sine of x is equal to 0. So we have to solve this trigonometric equation, and there's a lot of different ways to do it. You could simply just ask yourself, when are those two function values equal to each other, and look at a graph, or just use what you know from trigonometry to answer that. And we do know that it happens at pi over 4, and it happens at 5 pi over 4, down in the third quadrant. So that's the two places where that happens. But again, we want to go through and make sure we know how to do this algebraically using what we know from pre-calculus. So we could set it equal to 0, and then take that backwards and set it equal to one side versus the other. Again, that's where sine and cosine are equal, so there's nothing new there. Now, in trig, they usually teach you to square both sides of this, and that's what we're going to do. So that's going to be the cosine squared of x is equal to the sine squared of x. And then we could swap out one trig function with the other. So let's swap out the sine squared with the Pythagorean identity 1 minus cosine squared. So that's cosine squared of x is equal to 1 minus cosine squared of x, or 2 cosine squared of x is equal to 1. Cosine squared of x is 1/2. Upon taking square root of both sides using the square root property, we arrive at the cosine of x is equal to plus or minus 1 over the square root of 2. And we know that on the interval from 0 to pi, it's going to happen at two places. It's going to happen when x is equal to pi over 4, and x is equal to 3 pi over 4. The problem is the cosine of 3 pi over 4 is actually negative, and the sine is positive. So that is an extraneous solution that occurred from squaring. So that is extraneous. And keep in mind, again, our interval is just from 0 to pi. So we don't need to look at solutions in the third or the fourth quadrant for this. So we just have one number to check. In step 3, we know is to go through and evaluate the original function, which was called g in this case, at that critical number that we found. So g of pi over 4, remember going back in time, that is e to the pi over 4 times the cosine of pi over 4. So that's e to the pi over 4 times the cosine of pi over 4. And the best we can do for that is going to be just e to the pi over 4 divided by the square root of 2. And what we do know is this is a positive number, and therefore it is bigger than, well, actually no. We have actually there a 1 to compare it to. So we actually need to get the value of that so we know what we're dealing with. So we're going to go to a calculator and get that and report back in a second. All right, so this value from a calculator is roughly 1.55. And we do know that that's going to play a role in our final answer here. So step 4 again, just to recap, is where we look at the absolute largest and the absolute smallest to name our answer. And between a positive 1 and a 1.55, we know that 1.55 is larger. So f of x has an absolute maximum at the point pi over 4, e to the pi over 4 divided by square root 2. And we know that f of x has an absolute minimum at pi comma negative e to the pi, which is a negative number. And that right there is our absolute max and absolute min for this original function on the closed interval e to the pi.